So in this video, we want to talk about properties of logarithms. And there's going to be 3 properties of logarithms that we're going to talk about. But to find them, we're going to start with properties of exponents. And we'll use a relationship between these exponents and these logarithms. So the first property of exponents that we're going to talk about is, just to remind, if we take the product of 2 powers, we can just sum the exponents. So for example, if I have 2 cubed times 2 squared, that's 2 to the 5th power. And that's because I'm just multiplying 2 by itself 3 times, then 2 times, so then I multiply 2 by itself 5 times in the end. So to see a relationship between this exponent property and a property of logarithms, we're going to need to write down just the relationship. So if x is a to the m, then log base a of x is the exponent m. Remember that log returns exponents. And if y is a to the n, then log base a of y is the exponent n. And we're going to use this to go back and forth between our exponent rules and our logarithm rules. And the logarithm rule says, well, if I take the product of x and y, these 2 powers, and I look at what exponent I get. So I'm looking for the exponent on a to the m times a to the n. Then it's going to be the sum of the exponents on just a to the m and a to the n individually. But what that looks like in symbols, if I take the log base a of the product of 2 things, then it's the sum, and the exponent that I get is going to be the sum of the exponents of each of those individually. So that's one rule. Let's look at another exponent property. So remember, if I look at the ratio, then I'll subtract the exponents. So for example, if I have 2 cubed over 2 squared, that's the same as 2 to the 1 power, because it's 2 to the 3 minus 2. The corresponding logarithmic property is if I have a ratio of powers and I look at what exponent will be on that, it's the difference of the exponents on each of them individually. So the log of x over y is log of x minus log of y. And then the last property that we want to talk about is if I take a power and I raise it to another power, I wind up using the product of the exponents. So 2 cubed then squared is 2 to the 3 times 2, or 2 to the 6. For logarithms, this would look like if I had the power a to the m, we'll just call it x, then raised to the nth power, I get the product of the exponent and n. So the exponent is log base a of x, and then the power n, I'll multiply it by. So sometimes people talk about, oh, you're bringing this n down, so then it winds up here, but it's the product of n times the other exponent, log base a of x. Just like I have the product of exponents here. And that'll be my new exponent. So these 3 properties you're going to want to learn and memorize, and really you want to kind of learn them more procedurally and become fluent with using them more than just being able to state them. So the way to do that is to practice doing problems. And here's a couple examples of problems you'll want to practice with. So one example, you might be asked to expand something like log base 5 of 5x to the 5th over square root of z, and simplify. So when it says expand, it's essentially saying use the log rules to break this up. The first thing to notice is I do have that ratio, 5x to the 5th divided by root z. So I'm going to use the log rule, the second log rule, for what to do when I have that ratio, and write it as the log of the difference. So I get the log of 5x to the 5th minus the log of the square root of z. Now, here I have a product of 5 and x to the 5th, so I can use that first log rule to rewrite that as a sum. And here I'm going to rewrite this as a power z to the 1/2, so I can use my third log rule. So I now have expanded out with the sum, and now I'm going to write this as the product of 1/2 times log base 5 of z. Again, the log rule that I'm using here is the third one. The log rule I'm using here is the first, and the log rule I used here was the second. So those are all the things that I can do. Oh wait, I still can use the third one right here as well. So let me expand this a little bit more. So this is fully expanded, but I can actually simplify it a bit more. Log base 5 of 5, well, the exponent on 5 to give me 5 is just 1. So this is 1 plus 5 log base 5 of x minus 1/2 log base 5 of 2. And that's as expanded as I can get and simplified as I can get if I'm asked to expand. I might also be asked to condense, so let's do that. So I might be asked to condense 2 log base 5 of 2 minus 3 log base 5 of y. So if I'm asked to condense, then I'm going to do the reverse with the log rules. So first I notice I have a number times a log, so I'm going to rewrite that using the third log property as an exponent. The same with the second one. And now I see I have the difference of logs, and the key here, I need the same base on those logs to be able to do this step, but as long as the base is the same, then I can rewrite this as a ratio inside the log. And of course I can simplify the 2 squared. And this is the condensed form, and I've condensed it and written it as a single logarithm. The reason I'll want to do both of these things, expanding and condensing, is when we get to solving equations for exponentials and solving equations for logs, we're going to want to be able to go back and forth between a condensed single logarithm and an expanded form. And both of those processes will help us solve equations.